Is all this data really structured data, or are you seeing a shift as well towards streaming or semi-structured or unstructured for these use cases? Let's start with Sanjeev.
So thank you for asking that, because I think so. Like I mentioned, choosing your model is only one of many cost containment steps you can do. The second one is, what is your use case? In my opinion, and I'm making this prediction here on this webinar, is that in 2024 we will see the use cases that get funded and are deployed will be the ones where there is a very clear-cut ROI. For example, to answer your question, will it be structured, semi-structured data, streaming data? I think unstructured data is a clear-cut case, because what happens is that many organizations get PDF documents from Bloomberg, from Morgan Stanley, from Goldman Sachs, from all these places. Everyone is in a different format. A team is sitting there trying to decipher what's in each of these documents and then putting it manually inside a database. That is a ROI waiting to happen. It's like if you can put an LLM that can intelligently do extraction of entities and then classify or tag them to have a common meaning, is going to be highly adopted. But if you have a use case where you are putting the LLM because you're making your developers more productive, the question will come up, how do you measure productivity? It's so hard. So how do you know that LLM is useful? So this is going to be the second important cost-related consideration for GenAI.
And Subbu, what's your take on that, on the different types of data that you see demand for in terms of these, generative AI projects and other things like LLMs?
I think it's going to be all. I mean, I think every kind of data is going to get scraped up in this thing, right? It's going to get vacuumed up. With Lakehouse and Databricks, for example, we have opened the door to unstructured and semi-structured data. So JSON data, PDF, audio, video, binary, anything can be processed in Lakehouse, in Databricks very effectively. So I think you will see more and more of that for sure. Of course, structured is always there. That's the workhorse of the industry is structured data, right? So long story short, it's going to be all kinds of data.
It's going to be a combination. We are going to see a combination of operational use cases and analytical. We are already doing that. We call it HTAP. So OLTP and OLAP. Now it'll be OLTP, OLAP, predictive, and generative. And let me give you an example of what I mean by that. So let's say I want to find out which customers of mine have a propensity to churn and not renew their contract next year. Every major company has this problem. I can today either write a SQL statement and do a where clause where this is this, and I can generate a list. Or if I'm super smart in my company, I can do a machine learning model and I can do some sort of like decision random forest or some sort of way to predict which customers are. So now I've done predictive and I've done my normal query. Where GenAI comes in the picture is that I'm going to do this kind of machine learning, find out, tell me the list of customers that may churn, and then I'm going to send that list to my LLM and say, for each one of these, generate, because it's generative AI, generate a action plan based on everything that you see about them in my database. And now I may have a separate plan for Dawn, separate for Subbu, separate for Clinton, separate for me. And the salesperson can now have a more precise, personalized plan of how to go and try to convince this customer to renew. So this generative piece never existed. That is a brand new. We're plugging it on top of everything that we are doing today.
Great. And Don, what are you seeing as you meet with customers? Are you seeing the variety of data proliferate as well?
Yeah, I think that's really where big data came into play, right? The three V's, the volume, velocity, or variety. And that was really how I got into the big data space. I had primarily worked in structured data up to a point, but I happened to be working for an oil and gas company when one of our rigs, or at least a percentage of the rig we owned, blew up in the Gulf of Mexico and attracted a lot of attention. And what came out of that was a subpoena from Congress for us to go through about 6.5 petabytes of data and produce to them the results. And I mentioned that earlier, where I went to my data team and said, "Hey, what can you do for me?" And they kind of laughed me out of the room. But I was able to take a bunch of small servers and wire them together using this newfangled tool called Hadoop. And I was able to look at the data regardless of whether it was structured, semi-structured, unstructured images. And in fact, the issue turned out to be an issue with a PDF and just an old PDF being used on the rig, which caused them to use a lighter cement than they were supposed to down the hole. But without that capability to process it regardless of the volume, velocity, and variety, we would have never come to that answer. And so I think big data has been about the three V's for a while, but what we're seeing is, of course, AI more and more and ML want all of the data. They want larger and larger amounts of data. We've actually had data scientists for quite some time. They were called actuaries initially, and I think there's one that dates all the way back to the 1700s, where they simply looked at a set of data and then they used that to make a prediction. What we're seeing, though, is those data scientists are becoming very passionate about getting more and more data into their models because they recognize that that is what improves the accuracy of their models more than anything else. So you have to be able to go after all the data, regardless of its structure, regardless of how quickly it's being generated. You have to be able to process it. And then, of course, the size, the volume of it. Big data is a little bit of an overloaded term, but it really does mean the three V's: volume, velocity, and variety of data. So yeah, I think that more and more we need to get to all of the data. And in fact, I think you'll find that a very small percentage of data is actually structured, especially with the internet. So we need to be able to get to it all and incorporate it into our decision-making process. So yeah, definitely seeing that and more from data scientists wanting larger and larger amounts of data.
Great. Now, shifting the conversation towards efficiency. So, Sanjeev, you had hinted at this. I saw in a Towards Data Science article that 2023 marks a shift in focus to efficiency and the broad adoption of generative AI. What are you hearing? Any recent news that you've heard from any analysts or contacts that you have about the importance or the role of financial cost in data observability?
Clinton, when we started this year, I did a webinar for the Cube, which I do every year with 5 or 6 of my fellow analysts, and we do some predictions for this year. My prediction was how important cost optimization is going to be in 2023. Lo and behold, generative AI just dominated all conversations, and we temporarily shoved it under the carpet. So, but now it's bubbled back up because you cannot ignore cost optimization. It is so important. So I had done a chapter in Data Observability, the Reality book, where Unravel and a number of other data observability companies had all contributed a chapter. So I wrote the last chapter, which said the newest kid on the block for data observability, actually there are two: data FinOps and data BizOps. Data BizOps is a kind of a weird thing that I thought of, which is observing the productivity of your data. But let's not go there. Let's talk about the FinOps. Now, Gartner has, in the meantime, also come out with its definition of data observability, and now they're on to second version or iteration of data observability, and they've added FinOps into that. So I'm really happy to see that my ex-colleagues at Gartner and we are completely aligned in our definition of data observability, including FinOps. My take on this is that when we do data observability, actually data governance in general, we are working at the metadata layer. So we are taking the metadata of our data objects, which could be technical, like schema and distribution, or we're taking business metadata. FinOps is actually kind of a usage metadata. How effective is that environment where you are running? Are you underutilizing your resources? If so, maybe you should use a cheaper resource. How quickly are you running your jobs? Are they bottlenecked? Do you have the right SQL queries in place? So this is the financial aspects of data observability. So basically now we have converged Gartner and the industry definition. There are three major components of data observability: data quality, data reliability, and FinOps. So that's what I'm seeing in the industry.
Fascinating. And Subbu, would be interested to get your take on this. Have you seen organizations in your past succeed with this efficiency aspect, or struggle with it?
No, I think generally everybody struggles. And this was a lot of what I used to do in my previous role was essentially helping our SI partners get to the root of the problem, right? And unfortunately, when it comes to tuning Spark jobs, there is no easy answer. You have to get in there, and it's a very manual, very expert-oriented effort. So that's something where there is a lot of room for us to improve, and I think Unravel fits in perfectly. We definitely go there in the demo. I'll make one more appeal, right? I think as of course, companies need to do cost optimization to save dollars. I'll say this: I think humanity needs to start consuming less resources, right? I mean, we see all this craziness like climate change stuff happening. And with LLMs, it's just getting worse. The energy demands of LLMs are intense, right? There was an article I was reading that Microsoft wants to install nuclear reactors to power data centers, because unless we can blanket the earth with solar panels, there's not going to be enough power. Okay, so
interesting. Go ahead.
So optimize your jobs, use every tool necessary to cut that. And then you'd save dollars in the short term, and of course there's an altruistic payoff in the end, which is you're saving the earth.
I think Subbu, you can get me started. We can turn this from Unravel webinar into a TED Talk, because you've really touched a raw nerve. I think we should do another talk, Clinton, on sustainability, because
save the world. Yes.
Cost aspect. Yeah, I think it's really important topic.
Now, Sanjeev, if you have an LLM or generative AI, is that a guarantee of profitability? Like, we're hearing some big name companies out there creating these amazing models. For example, we see things like Copilot. Is that guaranteed to be a success now that they've built it?
No, not yet. But I'm a firm believer we will get there. I feel we are at the same stage when, let's say, printing press came out. So imagine this: what would have happened if we transport ourselves back to 1800s or whenever printing press came out, Gutenberg, Bible times. Mm-hmm. Do you think a printing press was a success when it came out? I don't think so. How could it be? Who would be the consumer of a printing press product when majority of the people had never been taught to read or write, because there was nothing to read or write? So it would have taken a few decades, maybe a whole generation, before people started reading printed material, because now they were being taught in school. Generative AI, I hear, is it overhyped or not? I think it may be underhyped. And maybe I'm a very strong believer in the force of technology's progress. And who knows? But the fact is that right now people are not productive. I learned something phenomenal. Last week, I was at an event. I met some people from a big pharma company, top 5 pharma company in the world. Everybody knows them, thanks to COVID. So the CEO has mandated every business unit head must have production AI use cases in a short amount of time. And these AI production level use cases cannot be Mickey Mouse ones like frequently asked questions, summarize it. What this company has done is they bought 10 million medical journals, and they basically want to have LLM go through this and try to find, are there any commonalities between these different documents from WHO, CDC, New England Journal of Medicine, and so on, and help find diagnosis, new remedies, new cures, new medicines, reduce the FDA approval time by half. These are all use cases that will generate an ROI. Are we there yet? No, but are we going to get there? Absolutely. It's just a matter of time. And we're moving faster than we ever expected. Like last year, we wouldn't even be having this conversation. It didn't even, this concept didn't even exist. But today it does, and it's moving at a rapid pace.
And Don, from your perspective, what do you think organizations need in order to scale? So as we start to think now about implementing at that level that Sanjeev described, what is necessary to put in place in order for an organization to have that capability to be able to start producing AI models and revenue at that scale?
Well, I think to some extent these observability platforms, because what you can't measure, you can't ultimately control, because you can't determine a baseline and a delta, and so you need to be able to take that holistic view of your ecosystem, and I know that's an overused term, maybe landscape, and take that data and use it to baseline and then determine, are you able to scale? And if you aren't, where are the problems that you aren't able to scale? The great thing about the cloud is it does build in this ability to scale, but it's not always, like you were saying earlier, it's not a guaranteed win just because the clouds have this ability to scale. You've got to be able to step back and look at things holistically and look at some key KPIs and determine how you're doing and where you're scaling well and where you're not, and then being able to go back and adjust those areas where you're not. I mean, it could be things like resources, you don't have enough data scientists, you don't have enough data engineers, or it could be things like processes. Perhaps your processes are overly burdensome, overly bureaucratic, and that's why you're struggling with scaling. But it all starts with the ability to see what's going on, make improvements, and monitor and measure whether or not those improvements are making a difference. And that's really at the heart of these observability platforms.
Excellent.